So we will continue today with the chapter on gears introduction. We'll define a very important parameter now, which is the pressure angle. The pressure angle is defined as the angle between the tooth profile and the radial line to its pitch point. In involute teeth, it is defined as the angle formed by the radial line and the line that is tangent to the profile at the pitch point. Let us see this figure to try to see how we define the pressure angle. So in this figure, you have, this is the involute. We have already discussed that teeth can be in several shapes, cycloid or involute shape. We have talked about these two forms. So as you can see here, whenever you have a contact between two teeth, you will be able to define, as we have seen last time, a contact point on the radial line joining the centers. Okay, so this is a point on the pitch circle, and it's defined as the point of contact between teeth lying on the lines joining centers. So this is your radial line joining centers. This is the tangent to contact. So it's tangent to the involute curve. Okay, so we can define the pressure angle as the angle between the radial line and the tangent line. Okay, this is alpha. Now, what is the meaning of this angle? You know that whenever you have teeth in contact, force will be transmitted through the perpendicular to contact line. Okay, so if we consider the transmitted force between teeth, it will be perpendicular to contact. And then here we have that the force will be along this direction. So let us say you have another gear from this side. It will act on this gear with a force that is towards normal to the involute. And then we can say that this force F can be divided into two components. One that will have an effect on rotation, and one that will not do any action. So you can divide it into two components: a normal component Fn, which will not contribute to rotation, and a tangential component Ft. So if we consider that, for example, this gear is the driven gear, then it is the tangential force Ft which will produce the rotational effect. This is why it's of interest to decrease the pressure angle, because this will increase the tangential force and therefore will increase the couple of rotation which will drive our wheel, okay, or our gear. Okay, so now we'll see in more detail two gears in contact and how force is transmitted between these gears. So in the following figure, you see teeth in contacts from two gears. Okay, now in general, if we just have two gears, let's say we have one gear that is driving motion and another gear that is driven. Okay, now for the driving gear, we supply a couple. So let's say A is the driving gear, and B is the driven gear. So we need to initiate motion of A by, let's say, applying a certain couple. So we can apply through a motor, we can apply a couple M. Let's say if M is in the clockwise direction, gear A will rotate clockwise, and it will transmit a force to gear B through the contact. Okay, so let's say here we have a contact point between these two teeth. Then whenever we determine this is the contact point, we have seen previously that at least one contact point lies on the line joining centers. Okay, so let us, this is the point lying on the line joining center is called the pitch point. So here we are doing the analysis at point P. which is the pitch point, lying on the line joining centers. And we have seen together that at any instant of contact, the pitch point is at a fixed distance from centers. So it's not changing location. And this is how, if you remember, we use this concept to define what is the pitch radius of each gear. Okay, so let's say this is the center of gear 1. When we determine the contact point along the line joining centers, we can say that this is the pitch radius of gear 1, and if this is the other center, this is the pitch radius of gear 2. Okay, now if we consider the force transmission, the force transmission will always be along the contact, the perpendicular to contact. Okay, so you know that any two surfaces in contact will transmit between each other forces along the normal direction. So here you have